Hello everyone, thank you for watching, and in this video I'm going to try to show you the solution of the tutorial question from the first week. Okay, so please pause this video and then read the question. So we have this compound CXHY. X just represents the number of carbon atoms and Y represents the number of hydrogen atoms that we don't know. And we have only 0.5 grams of it, right? And our objective, which is really important here, is to find the empirical formula. Now, remember that empirical formula means the ratio of X to Y, okay? They're not asking you to figure out if this is C4H8 or... They're not asking for a molecular formula. This is very important. Actually, they can't ask for a molecular formula. So this is the reaction. Notice how I put Y over 2 for water molecule, and that's because Y over 2 multiplied by 2 hydrogen atoms here is just going to give you Y, this guy here. Okay, and notice how I did not put anything in front of oxygen. Well, I should, because I have to balance this equation, but the reason I'm not going to touch this is because oxygen is given in excess, right? You're burning, you have a lot of oxygen, so you don't really need to balance for the oxygen. But if you want to do it, I mean, you could just add this to that, actually add 2x to this guy, and divide this by 2. But again, so if you read the question, you'll see that we're given another reaction. So this is 2OH minus, just represents sodium hydroxide. They just don't have the sodium ions here because, well, they cancel out. Okay, so they give you the mil and the molarity of the sodium hydroxide solution. Alright, so from there, remember that we have to figure out the moles of sodium hydroxide. So the first thing we're going to do is we're going to say that moles of that will just be the volume times the molarity, right? If you remember this equation, C is equal to M over V, and M is moles, V is volume. So then M is just going to be C. So if you do this, you're going to get this guy over here. So that means we have 71.2 times 10 to negative 3 moles of OH ions reacting. Okay, that's also the same thing as 71.2 millimoles, but we're just going to stick with moles for the sake of units because we're going to work with grams. Okay, so from here, our job is to figure out how much carbon dioxide, will react will completely react, that's what the question says, with this much of hydroxide. Okay, when you look at this reaction, we see 2OH reacting with only 1 mole of carbon dioxide, right? So what does that tell you? That tells you that this is the ratio of the reactants that will react. So from here, I can make a little proportionality chart again, that if 2OH reacts with 1 carbon dioxide, these 2's are and 1's are moles, then I'll form X moles of carbon dioxide if I have 71.2 times 10 to negative 3 moles of OH. Okay, hopefully this is easy, right? If 2 moles react with 1 mole of carbon dioxide, then only half of this will form carbon dioxide. So if you just do the cross multiplication and solve for X, you're gonna see that the amount of carbon dioxide is just 35.6 times 10 to negative 3 moles. Okay, which is okay. So now I have the moles of carbon dioxide formed from this reaction. Okay, which is 35.6 times 10 to negative 3. Okay, I'm just gonna isolate these guys from here. Okay, so from here you can also see that 1 mole of this reacts when reacting with oxygen yields X moles of carbon dioxide. Okay, at this point we should go back to the question again. So the question also specifies that we have 0.5 grams of the compound burned. Alright, so 0.5 grams of the compound yields this many moles of carbon dioxide. So I'm just going to write down 0.5 grams will yield 35.6 times 10 to negative 3 mole carbon dioxide. Notice how the question switched us to grams. Okay, we can't work with grams, so we have to come up with the molar amount. Now we need to convert this to the moles of CXHY. First of all, how would you find the molecular weight of CXHY? Think about it for a second. The way we're going to find it is we have X number of carbon atoms, so I'm going to say 12X, plus we have Y number of hydrogen atoms, I'm just going to say Y. Okay, 12X because one carbon atom is 12 atomic mass unit, and Y because one hydrogen atom is just 1 atomic mass unit. So once you have this and the amount of this compound, we can find the molarity, we can find how many moles of CXHY we have. To do that, I'm just going to divide this grams by 12X plus Y gram per mole. Right? Sorry about the ugly letters. But forget about the units, they're going to cancel out, and you're going to end up with 0.5 divided by 12X plus Y moles of CXHY. So when this many moles of our compound, which is only 0.5 grams, right, reacts with oxygen, we produce 35.6 times 10 to the negative 3 moles of carbon dioxide. Alright, so from here I'm just going to make a little proportionality chart, and then we're going to solve for X, and then alright, this is our proportionality chart here, and all we need to do here is just to isolate Y in terms of X or X in terms of Y. So our equation is just going to come from cross multiplication, so let me do that for you as well. So to solve for X in here, there's a good shortcut. We could just multiply this side by 1,000 and this side by 1,000. Reason is because we want to get rid of this 10 to the negative 3 part of it. Okay, so when I do so, we get 500x divided by 12x plus y equals 35.6, right? Hopefully you remember math from this point on. So all you need to do is just isolate y or x, whichever you feel comfortable with at the end. And when I did it, I got y equals 2x. Okay, that's all I got. And if you remember that our compound was CXHY. Okay, if y is equal to 2x, then our compound is going to become CXH2x. So that's your empirical formula, CH2. Okay, oh, one more thing. When I did this math, actually, I didn't get exactly 2x. I got something 2.04x. Let me write it down, 2.04x. And this is normal because not everything will just match up in chemistry. So just say that's 2x, and then you're going to arrive at CH2. If you have any questions, please don't hesitate to ask, and thanks for watching.